All right, gang, so what we've got here, so what most likely you'll be working with is this right here. I always recommend 12 gauge wire. 14, a lot of homeowners try to save some money, go 14 gauge for their lighting system, or they derate a circuit, and then guess what? You pop the breaker, because you can only put 15 amp wire, 15 amp breakers or fuses on 14 gauge wire. So I use 12 because it gives you 20. And 20 is the industry standard. So always recommend that. But since the project I'm working on is a chicken coop, and I've got some scrap THHN, essentially this is what would go in conduit. There's 3 different wires here, obviously different colors. The color coding matches similar to what you would find inside of that Romex wire. So, and mine went in my scrap bin, and I know this is all good wire. We just clipped it off and it was going to go to the scrap yard. So I have to wire some outlets, and especially for the project I'm doing with the kind of boxes I'm doing and the kind of covers, the raised covers, we can use these. It makes it a little bit easier. But we're just learning the fundamentals today anyway. So you've got your hot, you've got your ground, and you've got your neutral. Right? Your neutral's white, your hot is black or red, depending on what kind of wire you bought, or if you have a black and a red, obviously that means that you've got 2 different hot lines, one being 110 volts or 120, or some of them just take the average and say it's 115, and then 2 of them together would be where you typically would hear somebody say, oh, I have 110 or 220 or 240 or 230 because they did the 115. And so essentially it's roughly all the same. You know, you're not really talking much. It's just the vernacular that you'll hear different guys use. And I'm sure someone will correct me in the comments. But that's just the way us field taught techs have always just known it. So there's your wiring 101. So this is THHN typically because it doesn't have the outer jacket on it. Like your Romex wire, the yellow wire we just showed you. The Romex wire is jacketed, so all you have to do is staple it inside your wall cavity or wherever it has to go, and it's thermally insulated. If you start running that within conduit for too long of a run, it's going to, the resistance and the insulation on it from the resistance of the wire will actually cause it to overheat. So, you know, that's just... that's something you want to bear in mind. So, you know, that's why you don't run your Romex inside a conduit or raceway. You're going to want to use THHN, which is, you buy them in an individual spool. They sell them, I mean, I think the biggest they sell them is 500 feet for a spool. And you got to buy one of each kind. So it gets a little costly if you've got a bigger project. Then obviously, yeah, you've got, you know, but it's sometimes a lot more convenient to run conduit on the outside of the wall than it is to open up a wall and snake wire. And I'm sure a code guy would tell you you're probably supposed to open up the wall and staple it every, geez, I can't even remember off the top of my head, every 12, 16 inches is supposed to be stapled to suitable surface and yada yada yada. So, but that's your wiring 101. So we'll give you a little bit more about the wiring here in just a sec. Well, actually, we'll give it to you right now. So the hot line, that takes your voltage, that takes your power to your outlet, for example, and the neutral takes it back to the box because we have alternating current. So it wants to return back to its source. So it comes from the power pole, and it wants to come back. It wants to go out. We're essentially tricking it. That's why power doesn't just flow wherever. It doesn't just keep drawing juice because it's right here. It's waiting for something to happen. So it goes in. Well, I got it reversed, but it goes into this outlet. You plug something in, and then it goes now out to your appliance, whether it's a cell phone charger or whatever, a light. It goes through the light bulb and back through here. If your neutral separated, it won't just light up your light bulb and do nothing because it has to go back to, we have to trick it. It knows, it can see the road back to its home, and it has to get back to its home. And so if that neutral's not connected, and it can't somehow get to ground, because even when it goes to ground, it wants to go to neutral. I know this is a lot to throw at you, but I figure wiring 101. This is some nice stuff to kind of have in your toolbox, in your wheelhouse, especially if you have an outlet. So something so simple, you know. And as you get more comfortable, you can be crazy like guys like me, and I deal with this stuff hot typically. You you know, when you start getting into, 400 volts and the amperage is higher than 20, you start doing double 30 amps, and it only takes half an amp to stop your heart, I believe, or half a milliamp. I think it's half an amp or quarter an amp, tenth of an amp. It's something low. It's less than half an amp, and half an amp or less. So it's one of those, and you can probably Google that for the information. But that's one of the reasons why your outlet or your you have a GFI in a bathroom or a kitchen, because as soon as it senses millivolt or milliamp draw, it shuts off. You drop that hair dryer in the bathtub with you, you don't get toasted and stop your heart and die right in the bathtub and electrocute yourself. That's your protection, because the breaker is not going to, or the fuse is not going to pop as fast. By the time it travels through that current, you're already toast, and that GFI will do its job. So and then we have a ground essentially on this system, and a ground essentially is protecting it. So right, it's going to force your breaker to pop. You're going to know if something's up, whether it's your outlet is touching the box, or maybe the neutral or the hot has frayed a bare spot in the wire and now it's touching the box, or it's touching something it shouldn't touch. Essentially, by having the grounding system, as my father used to say, it's a backup neutral, which in essence it kind of is. It's a spare neutral, it's a protectant, but it's also, taking anything that touches that box, takes it right back to the box. So if it somehow grounds out, it's going to draw a lot of power real quick, pop that breaker, pop that GFI, pop whatever, and it's a safety. So we want to have all three of these wires, and if you were to hook up a dryer or something where you'd have an extra hot, an electric dryer or electric hot water tank, whatever it is, you're going to have that extra hot giving you that increased voltage, which will decrease your amperage. So, and we can learn more about this in other videos, but that's wiring 101. For that's THHN. Homeowners might not deal with that as much as I do. I have it here just because we're going to do an outlet project here in a minute, and I'm going to use that just for giggles. But so your typical Romex is right here. I got these fancy little strippers that I got from the guy, a friend of mine who works at Home Depot. He told me to buy these, and I did. These are nice Klein tools. I like them. I typically don't use this set that often, but I'm also not working with Romex as often either. So as you can see in the front there, this one here actually strips your 14 gauge wire. That'll strip your 12, and those are for the individual wires. So we'll go through this real quick. We'll cut you off we'll use one of these for the wire anyway, or for one of the outlets. So so we cut you a chunk of wire in order to strip the jacket. If it's this small, you can really pull it off just so you have your ends to wire in an outlet or something. But if this will come through the box, as we've discussed, and what we're going to do is we're going to strip this wire. So we know it's 12 gauge wire. So we're going to, normally in a normal box you would probably peel about that much back, so you have some room to work with, maybe a little further back. And then you just, with these set of pliers, nice and handy, just bite into them, and you're going to hold the wire that hold the opposite end, and boom, clip. And obviously, because there's nothing attached to it, now you can just peel it right off. It comes, as you see in there, it's got a paper jacket inside of it, and it's got this rubberized jacket, plasticky jacket on the outside. And then you've got your hot, your ground, which is bare inside of Romex, and your neutral. And typically you just tear that piece of paper right off of there. So that's all there is to it. I mean, and then depending on the kind of Romex you buy, this is 12-2, which means it has two insulated wires. Usually it's a ground and a neutral. If you see 12-3, that means it's got two hots and a neutral, and they don't count the bare ground as part of that too, unless you're buying extension cord wire, at which point you'll notice it'll throw you off, because it's always threw me off at first when I first got in the industry. They'll say 12-3 because they're referring to the ground, which is jacketed, like this THHN has a green jacket on it. And all the wires the same, obviously. You want to run the right wire. You want to make sure you size your wire for the job, the application. If you're adding an outlet to a run that's off a 15 amp breaker, or a 20 amp breaker, for example, you're going to want to, and you're continuing on with the run, and saying adding an outlet from one box and you're just going one more outlet, you're going to want to have the proper wire. So You can oversize your wire, you can't undersize your wire. So if you're adding an outlet to a 15 amp circuit, you can go 12, and I'm sure there's probably some code guy that says that's not code, but there's no harm in adding a larger wire afterwards. So what you're going to do is you're going to have this wire, and you can run 12 gauge wire because it's not going to affect the 14, because the 14 will burn up. It's over 15 amps, but the safe mark is 15. So essentially this is like 22, 24 amps this will burn up at, so they rated it 20. So that's why you want to make sure you don't oversize your breaker and undersize your wire, because if you draw too much current through it, the breaker will not pop and the wire will burn up, and then you could potentially have a fire in the wall. You'll have a whole bunch of intermittent electrical issues, maybe just the neutral burn up in here, and you're like, these outlets don't work, and you check the breaker hasn't popped, but some of the other outlets still work, and you get a whole bunch of problems. Now you got to tear open walls to find out where the wire is, and you still have exposed burnt wires in your wall, which still can also, if they didn't cause a fire the first time, they can still, being live and in a wall and not properly capped off, that you potentially could have an issue. So that's why it's always good. Wiring 101 right there. So we got I hope that crash courses you there on wire, and we will we'll catch you guys here in just a second with another little bit of Electrical 101 with Factotum Jack Home Repairs. Don't forget to like, subscribe, and we'll catch you guys soon.